our seniors robot course. I've modified this now to version 5. And we're up to session 3, which is other projects. And here we've already looked at traffic signals, garden control, and now we're going to do security systems. And the idea is that we want to detect if there's an intrusion in our house. And we could detect the person with a time of flight because they will become an obstacle in the zone, one of the zones of interest. But closely related to that, there's a presence sensor. You could also use a fingerprint recognition unit or an RFID unit to access your front door. There's also thermal detection, and space detection is done primarily with the PIR. For perimeter detection, we use the limit switches, or alternatively, there's a hall or an IR switch could be used instead. And besides detecting a zone or a perimeter, you might like to secure one of your assets individually. So if there's an asset that has been removed, you can detect that. You can also combine these security systems with cameras, and in particular, I'll be looking later at AI cameras as part of a security system. So what are the projects? Well, the first one is just a simple push button. And in this project, we're going to use a Atom S3R computer with a dual button. And it's very simple. This is what it looks like. We just have a simple Atom computer, and it's connected to a Atom motion base. And on port C, we've added the dual button unit. And you could use that as a personal alert alarm, or you could use it to activate or acknowledge alarms. But this is like a unit test, and we're beginning to learn how to use external devices like the dual button on our Atom computer. And if you look at the combination of the Atom computer with the motion control, you can see that we've got ports B and C now available, and they become GPIO 5, 6, 7, and 8. And since we've got very simple switches, we can access the pins directly for these. And we paint our screen like this, and we activate the software user interface for UI flow with the pin and the button. We want those enabled. And what does the code look like? Well, it's actually quite simple. And what we're doing here is on setup, activating pins 7 and 8 as input switches, and we'll show the status of those by painting circles on our LCD, and we'll show what they are with labels. And in our loot, all we do is just go round and look if the values on those pins change. And those pins can be anything from push buttons to simple limit switches. And we've got a simple alarm system already just using what we have here. So that's our first. And we might go across to the desktop unit and have a look at that. Here we're testing the dual button with a Atom S3R, and the Atom S3R sitting on top of a motion base. And that allows us access to the ports. So we're using port B, and the dual button is connected to port B. We've replicated the buttons on our push button. So when we press the buttons, the red button, should go white. So it's been activated and detected. And when we press the blue button, it'll go white. and it will show the status as a numerical value when it's high or low, and similarly with the other one. And that's testing as a unit test the dual push button on the Atom S3R computer. On our next security system project, we get a little bit more complicated, and we have a look at the Project 6, which is the basic security system. So let's have a look at that. Just expand on that and just open up the text size. And the objective here is that we are going to use push buttons to turn on and off relays. We're going to test for interrupts, and we're going to scan sensors, limit switches, and PIRs. So in a sense, we're not going to install this security system. It's more like unit testing of all the individual devices, then combining them to make sure that it still works. And then we can start our design of the actual security system. So for design-wise, we're going to use push buttons, a port expander. We're going to scan sensors, and we're going to use relays. And I'm going to try one relay and two relay units. Hardware-wise, we're going to use the same computer, the Atom S3R, and we've covered that quite extensively. We'll be using limit switches, a dual button, and a two relay. So this is what our two relay looks like. But if we don't want to, we could use a single relay unit. I prefer the two-channel relay because it's got status buttons, and you don't have to have your final connection to the external electrical circuit. When you're testing your software, you can just use the status buttons. And of course, the PIR will be quite handy for detecting within a security zone. And connection-wise, we'll look at how we put it all together. What we've got is our Atom S3R computer sitting on a motion base, and connected to port C, we've got our dual button, and that can be used to activate our security system. The port expander, you can see that the color changes there from red, and that means that we're on a I to C port on port A, and we then convert to GPIO devices. So these are quite simple. And in my simple security system, I've got two limit switches, a Hall effect device, which is connected to a small magnet, and that will act as a switch when we release the magnet or take the magnet away. We also have a PIR and a relay. So we've got a very basic security system. And we can add an external alert, sound alert, like a buzzer, if we want to, because we've still got port C available. And I'll be adding a MIDI synthesizer with a speaker that will indicate, will give a different tone for each device which has been triggered. So these are the ports that we'll be using. We're using all of them. And port A this time will be used as our port expander. So software-wise, a little bit more complicated. We're still using UI Flow 2, and here's the screen that we paint and the resources we're using. Same as last time, the push button and the pins. And code-wise, let's have a look at it. Not that much more complicated. We're still activating pins 7 and 8, and we're checking those out. And if the blue button indicates that the security system has been activated. So we can actually show that on the LCD. And that's the code. So stay tuned, and we'll have a desktop demonstration of that. And the results, we're able to get it all working. Any issues, relay and sensors, software for that. I found sometimes the activators like the sensor, the relays were not reliable. In this security system, we're using the Atom S3R with the dual push button over here, and that's connected to port B. And that was demonstrated in the previous video. But on port A, we've also added a port expander. So it comes in the I2C port and makes available GPIO pins. And there are 6 of them. We've got 2 limit switches, a PIR, a Hall switch, and 2 relays. And to demonstrate, we've got values, and instead of digital values, we're actually showing the analog values. So if I go to the limit switch over here and change it, you'll notice that it goes down from 1023 down to 15. And I can do the same on the adjacent limit switch. Press that button. You can see the light on the limit switch comes on, and it also goes down to 15. And we can do the same with the Hall device. So the Hall device is depending on a magnet, and if I have to get the right, there we go, we've detected the magnet. And if we go to our, you can see the first line on our display shows the changing values. So when there's a magnet present, it's 27. I'll remove the magnet, and it's 620. And if we want to turn the relays on, we can press the buttons. So here we're pressing button A, the blue button, and it's turning our relay on and off. And our PIR is activated because I'm always here. And that's a simple security system based on the Atom S3R, the port expander, and it gives me access to GPIO pins. So here are some of the challenges for you. And the first challenge I'm going to illustrate is a more complex security system based not on the Atom S3R, but on the M5Stack Station computer. And this is what it looks like on my desktop. So if we expand it, you can see the devices. And because this computer has 6 ports, we don't have to use a port expander, but it is available if you want it. And we've got a slightly bigger LCD. And here we can see LS stands for limit switches, which ones are activated, and which PIR and the key switch if it's activated. This time we have 3 buttons, and that can be handy if we need the additional functions like resetting the alarm and acknowledging alarms that have gone off. So I'll be using all of those in my software. The objectives here is to design a simple security system with both perimeter and space detection. And we're going to provide limit switches, PIRs, key switches, plenty of feedback using the LCD, and also on our station computer, we have a RGB for each of the ports. So we can show the status by color changes on our sensors. And we're going to provide interrupt as many as possible so that we get a more reliable sensor detection. And since we've got a PI, a TOF, we can then measure distance before a sensor. And that can be used to detect if someone's coming up the driveway. Design-wise, we're going to use the buttons and the display on the station. And for extra units, we're using the key switch. And we're using the station button, the LCD, and we're going to supplement that with a 7-segment clock display. So hardware, same devices as we had before, but the connection this time looks like this. So we've got on port A, we've got the time of flight, and we've also got the digi clock that tells us which zones have gone off. Limit switches, we've got two of them. They're on port B. And on port C, we've got the key switch and the PIR unit. So that's the device. And the software, it's going to get a little bit more complex this time. Same tool for developing our software, UI Flow 2, and the code-wise, just a build-up. It's just building up a little bit more. We're activating the I2C bus, and we're setting the limit switches directly there, and the key switch. And the advantage of that is that we've got interrupts, and you can see the interrupts are over here for the key switch. It's the right on the bottom right, we've got the event function for our key switch. And on top of that, the green ones are the event functions for our station buttons. And we're displaying the results, and we have a function for resetting. So the loop is actually quite simple. It's updating the buttons and then getting the distance from our time of flight, and that it calls the LCD to display all the results. And in displaying the results, you can see that we're displaying the status of the limit switches, the PIR and the key switch, and we're updating the RGB LEDs on the station computer and showing the labels for our push buttons. So stay tuned and we'll have a look at that as a desktop demonstration. This is a demo of a security system using components from M5Stack. So the computer is a station computer. This is the computer here, and it's got plenty of ports. So we've got 6 ports. So we've got port A, B, and C. The left one is A1. On the right is A2, and we've got B1 and C1. And connected to those, we've got limit switches for our perimeter detection. So if we press that button, we will get an indication that the second limit switch has been pressed, and that is reflected on the screen. You can see that here. And I'm going to do it for the left limit switch. I'm going to press that limit switch now. And that will also be indicated both on the screen, but also on the RGB LEDs on the station computer. So we've got them all activated, including the PIR. We've got a PIR here, and that's on C2. And now I'm going to activate the key switch. So when I press that one, it will also tell us that it was activated. And to clear all that, I use the buttons on the station computer to reset everything. There we go. We're resetted the status back to a ambient condition. And that's a security demo using the M5 station computer along with various units for security detection.